Okay, so very quickly, I just want to do a quick overview of what we are going to be doing for the next 2.5 weeks or however long we're going to be in school. So we really only have these 4 days of this week, next week, and then the third week of December, you guys only have 4 days of school. So we're down to like 13 days from now until the end of the semester. So that being said, today we're going to introduce bonding. Tomorrow we're going to talk about ionic bonding. On Thursday, you guys are going to have your first quiz on bonding. Then next week on the 6th and 7th, we are going to do task cards on covalent and ionic bonding, and you're going to have another quiz on the 8th. I am going to put together a Mastering Chemistry today. I will put it up for you. It is due on the 9th. That will be your last homework grade for the quarter. We're also going to do metallic bonding these 2 days. That leaves us to the last week that you guys are in school. We'll be spending the 13th and the 14th reviewing for your final. Your guys' final in this class is going to be on Thursday the 16th. So that's it. There you go. So it'll just be the semester final. So we'll spend these 2 days reviewing. I can't remember if I see you on the 15th or not. I don't think I do.
Why?
Yeah.
Okay, so are we doing what we did last year where each final's on a different day?
So you have second, fourth, and fifth period finals are, nope. Second, I have the schedule. Hold on a second. On the 14th, 12-14, you have fourth period final. On the 15th, you have your second, fifth, and seventh period final. And then on the 16th, you have your first, your third, and your sixth period final. So each final is, looks like they're about 1 hour and 10 minutes long. So 70 minutes. Yeah.
What's the final
No. Any other questions? Alrighty. Okay, so that should give you guys an idea of where we're going here. Also, we are going to have one more lab thrown in here. That'll probably be on the 3rd that we're going to do one more lab on I definitely want to get one more lab grade in there. So you guys will have your project for your periodic table. You'll have the lab that we just did, the easiest pi lab, and then you're going to have one more lab in that lab grade. Okay, so all of that being said, today we are going to introduce chemical bonding. And we are finally past talking about individual elements, and we are going to start talking about bonding, which is awesome. Okay, so what is a chemical bond? A chemical bond is when you have more than one atom together. The attractive force between atoms or ions that binds them together as a unit. We make them into a unit. Atoms form bonds for 2 reasons. Number 1, it decreases their potential energy. They would like to be in the least amount of energy possible. And number 2, it increases their stability. So it makes them more stable, and it also means that they need less energy to stay in that stable spot. Those are the 2 best reasons that atoms bond. We have 2 main types of bonding that we are going to talk about in this class. We are also going to talk about metallic bonding, but to start with, we're going to talk about the 2 main types of bonding, which are covalent bonding and ionic bonding. Here's the difference. Covalent bonding, electrons are shared. Remember that your electrons are the superstars of chemistry. When we are talking about bonding, it's all about electron movement. Protons, neutrons, they don't do anything when it comes to bonding. They just sit in their little nucleus, happy and content. It's the electrons that are moving around. So when we talk about covalent bonding, that's when we have 2 atoms that are sharing an electron. This happens in a molecule or a polyatomic ion. In ionic bonding, these are your ions that we've been practicing for the last however many weeks. That they become positive or negatively charged ions, they gain or lose electrons, and they are held together by electrostatic forces when they transfer the electron from one atom to the other. So a great example of this would be NaCl, also known as table salt. Sodium gives its one electron in its valence shell to chlorine, and they form an ionic bond. All right, do we have questions between these two? Quick review. I'm a little confused on what I've taught and what I haven't, so I'm going to ask you. Covalent bonds typically happen between what types of atoms on the periodic table? Yep. Two nonmetals, yes. And ionic bonding happens typically between what? What's that, Sam? A metal and a nonmetal. Very good. So one way we can identify if they are sharing electrons or trading or giving and receiving electrons is by the type of atoms that we have in the compound. All right, there are two types of covalent bonds. We have a polar covalent bond. And in a polar covalent bond, this means that there is an unequal attraction for the shared electrons. Basically, they don't have equal custody. One side of the molecule has the electrons more than the other side. So in this case, it would be that the side that is larger or that is slightly negative gets the electrons more than the other side. I usually say that they're hogging it. One side is hogging the electrons from the other side. They don't share equally. Kind of like siblings. Typically, siblings don't share equally. If you ask at my house, no one ever thinks it's completely fair. It's always one person is getting more than the other. So we have two different symbols. This little bitty, this is a lowercase delta, and the lowercase delta with the negative, with the little minus sign, and then we have a lowercase delta with a positive sign. When you see that on a picture like this, or on an atom, or on a compound, this tells you that one side is partially negative and one side is partially positive. They're not completely negative or positive, but it's a partial charge. And the reason, so when you're looking at these and you know that one side is partially positive and the other side is partially negative, which side has the electrons more? The partially negative side. Why?
Because electrons have a negative charge.
That's right, because electrons have a negative charge. So if the electrons are hanging out in this part of the particle more often, then that side is going to be partially negative, which leaves our other side to be partially positive. Non-polar covalent means that the electrons are shared equally. Looks like this. We have two little nucleuses, and the electrons are perfectly shared between the two. We also say that this is symmetrical electron density, meaning the electrons are the same all the way around both. Okay, so do you have any questions on the difference between polar covalent and non-polar covalent? Yeah.
Non-polar covalent can only be made up of the group 4, right?
No. Like, for example, if you had two fluorines bonded together, they would share equally because they both have the same amount of same amount of protons in their nucleus.
Well, it's because two fluorines don't equal 8 atoms, so that was thinking.
They share. This is covalent bonding, so they're sharing. In the example of two fluorines, how many electrons does fluorine have, Braden? 7. Right?
Yeah.
So what they do is they both share these electrons here equally. Yep. They're not giving or taking, they are sharing, which gives them the bond. All right, so a nonpolar covalent bond where our bonding electrons are shared equally between two atoms. Here you see we have a chlorine, which is basically the same example as the fluorine that I just drew on the board, where each of them has 7 valence electrons, and then they share those 2 electrons in the middle. They share them equally. There is no pull one way or the other. In a polar covalent bond, for example, here we have hydrochloric acid with a hydrogen and a chlorine. So hydrogen shares its 1 electron and chlorine shares its electron, but chlorine is stronger and it has more protons in its nucleus. So chlorine's like, oh, thank you so much, hydrogen. Thank you for sharing with me, but I'm just going to keep your electron most of the time. Which means that this is a polar covalent bond where the one end of the compound is partially positive and the other end is partially negative because chlorine has the electrons most of the time. The third type of bond is our ionic bond, and this is a complete transfer of electrons. In this case, you see that sodium is giving chlorine its electron. So sodium no longer has that electron, and it has transferred custody to chlorine. Do you have questions on these? All right, awesome. So when we are determining the type of bond, we are going to use the difference in electronegativity. Let's go back to our thought process about periodic trends, and we talked about electronegativity. Remember that electronegativity is how much an atom is able to attract electrons. How much does it want an electron? How much can it bring in an electron? And hold on, I want to show you guys something. So if you go to Schoology, I hope I put that in there. There it is. Sorry, I put it in tomorrow's folder. But there is a periodic table of electronegativity, and when you open that up, it's just a periodic table that just shows you the symbols and then the electronegativity value that we are going to use, so that you can actually look at those. There are also electronegativity values on the periodic tables that you guys have. They are the second number from the bottom. So, for example, if you looked at it was around the same time last year when I started looking at the electronegativity values on this table that I was like, if you look at the electronegativity values, they are the second from the bottom. So, like, for example, if you look at lithium, and on this table it says that lithium is 1.0. On your chart, it says that it is 0.98. So it's just rounded to one more decimal point. But you can use the numbers on this chart if you want. I think they're close enough. Okay? So we need to be able to look at our electronegativities. Remembering what electronegativity means, which is how much an atom wants the electrons. So, for polar covalent bonds, when we are talking about covalent bonds, the first thing you're going to do is determine that you have a covalent bond. So, do I have 2 nonmetals that are bonded together? When the answer to that is yes, the next thing you're going to do is look at your electronegativities, and you are going to say, okay, what is the difference in electronegativity? So for this example, we would look at the electronegativity value for hydrogen, and we would look for the electronegativity value for chlorine. So what is the electronegativity value for hydrogen? 2.2. And what is the electronegativity value for chlorine? 3.16. So let's just make it 3.2 to make it easy. So the difference in electronegativities would just be 1. For polar covalent bonds, the higher electronegative atom is going to be your partially negative, and the lower electronegative atom is going to be your partially positive. So for example, here, hydrogen was 2.2, right? Chlorine was 3.2. So chlorine has a higher electronegativity, which means it's going to have the electrons most of the time, and that will be your partially negative end. You know what? Wait. Whoa. What are we doing here? When we're talking about ionic bonds, which are made up of what, Olivia? What types of atoms are ionic bonds? Very good. When we talk about ionic bonds, we have a metal and a non-metal. Whichever one has the higher electronegativity, the highest electronegative atom, forms the anion. It gains the electron, which makes sense, right? Because electronegativity means it wants to gain an electron. So whichever one wants to gain the electron more is going to form the anion. It is going to gain an electron. The one that has a lower electronegativity, doesn't want the electron as much, is going to give away the electron. Remember how I told you at the beginning of the year, everything we learned is going to continue to build? So we're building on our electronegativity information. Does that make sense to you guys? Let's ask a question. Okay, Sydney. When I have two atoms and one loses the electron, does that have the higher electronegativity or the lower electronegativity? Very good. It has a lower electronegativity. Are we tracking? Does that make sense? Okay. Oh, looky there. I didn't realize it was in the slideshow. Once again, here is the table that we are using to determine the type of bond using the electronegativity differences. So we can first start and look and see if we have two nonmetals or a metal and a nonmetal. The next thing we're going to do is look at our electronegativity values, and we are going to see what is the difference in them. What is the difference? Remembering that our trend for electronegativity increases from the bottom to the top, so we are more electronegative at the top of the periodic table than we are at the bottom, and also from left to right. So the electronegativity increases as you go across the table. You just look at the top, like period 2 right here. You can see we go 1, 1.5, 2, 2.5, 3, 3.5, 4. It increases as we go across the table. Those elements want an electron more and more and more. That's a quick reminder. Okay, so notice that this chart here is faded, like an ombre fade. And when we are looking at differences in electronegativity, the difference in electronegativity also determines bond type. Using this chart, what it is telling you is this. If the difference in electronegativity is 0.3 or less, it is a nonpolar covalent bond. If the electronegativity difference is greater than 0.3 to 1.7, then you have a polar covalent bond. If your electronegativity is 1.7 or greater difference, then that is an ionic bond.
Is this true every time?
No, it's not true every time because this is a fade. It is not like a definite line. You notice it doesn't have like an orange block, a yellow block, and a green block.
Yeah,
It nicely fades. Yes. Right.
Are you gonna want us to be like rounding like we did just now on the one example for hydrogen and chlorine? Or
Yeah, we're gonna use the values on the chart that I just showed you. This chart, which are rounded, just to make life easier for everyone. Good question. Okay, so let's practice. So what is the electronegativity difference between Cl2? Let's see. We have people who have talked today. Jocelyn.
wait, what was the question?
What's the difference in electronegativity between Cl2?
Because it's at the top.
Nope, it's not at the top.
Oh.
What's the electronegativity for chlorine? is, you have to look at your chart. I don't know what it is.
S.
No, I want to know the electronegativity. Second, can you show her where it is right now?
It's like 3.16.
Okay, so we're gonna go with 3.2. Now you have two chlorine atoms here in this compound. So it would be 3.2 minus 3.2. So what's my difference?
It's 0.
It's 0. Very good. So if your electronegativity is 0, which type of bond are we going to have here? Non-polar covalent, polar covalent, or ionic? Non-polar covalent. Very good. Now let's look at HCl. So Mason, what is my electronegativity value for hydrogen? 2.2. And what about chlorine? 3.2. So what is the difference in electronegativity there? 1. So which type of bond would I have? Polar covalent. Now let's look at NaCl. So Dylan, what about sodium?
0.9.
0.9. And what about chlorine?
3.2.
So the difference is? Pencil math under pressure.
2.1.
There you go. Very good. Now, what type of bond does that indicate that we have? An ionic bond. Very good. So anytime you have a binary compound, you should be able to look at your differences in electronegativity and be like, oh, that's what it is. Now, as Brayden pointed out, these are not exact, right? These numbers are not exact. This is an ombre fade. Right on the lines, occasionally, there will be things that are different types of bonds. But it's a good strategy to go for. What's so funny?
That 3.2 minus 0.9 is not 2.1.
Yes, it is.
2.3.
It was
3.2,
3.0.
that's Yeah, right there it's 3.0. We said 3.2.
Oh. Well, there you go. Whatever. Okay. So remembering that polar covalent is an unequal sharing of electrons. This results in an asymmetrical electron density. The density of electrons are more towards the atom that have a higher electronegativity. So here you have a hydrogen ion, you have a chlorine ion. They're both pulling on the electron, but the chlorine is winning because it is stronger. Its electronegativity is higher. I feel like I'm saying the same thing over and over again. Are we good? Non-polar covalent means they are the same strength. They are pulling equally on the electron. They are sharing those electrons equally. Those electrons are found smack dab in the middle. Yes?
Okay. What is the term greatest end?
Greatest end?
Yes.
I don't know.
It's on the homework. It says which of the following molecules is the most order between the bonded atoms in terms of the greatest end? E and D.
Which side is more dense?
I had to go with that.
E and D was the
Greatest end. I would guess it means which ones have the more electrons, but I don't know. I'll have to look at it. How much more do we have? We're almost done. All right. Ionic bonding, remember, is a complete transfer of E and D stands for electronegativity difference. Sorry it took me a minute because you were reading it in and I was like, yeah, E and D. The ionic bonding is a complete transfer of the electron resulting in oppositely charged ions. When you transfer, now we have a sodium that is actually a plus, the chlorine is actually a minus, and the chlorine just has the ion. So let's use the electronegativity values to classify some bonding. What is the difference between sulfur and hydrogen? Okay, Chandler. What's my value for sulfur? 2.6. And what's the value for hydrogen? So what's the difference? 0.4. Very good. So if we have a 0.4 electronegativity difference, what type of bond do we have? Polar covalent. Very good. Good job. All right, going back. How about cesium and fluorine? Haley, what's the value for cesium? 55. 0.7 and fluorine? That's okay. 3.9, let's round to 4. So what's our difference? .2. Very good. So what type of bond do we have? Ionic bond. Very good. All right. Hayden, your last. How about fluorine? 3 and phosphorus? 2.2. So what's the difference? 0.8. And so which type of bond do I have? Polar covalent. Very good. Do you guys have questions on this? Okay. So I want you to go ahead and open up your classwork, homework for today. You've got the next 15 minutes to work on it. END stands for electronegativity difference. Also, I'm terrible. I'm not verbal. It's asking which one you want. Yep. You look at your own information, and I can't read it. And if you have to read it, minus 3. Yes. But that asks for a polar covalent. Yeah. Absolutely. Thank you.